This week we will learn how to read and write a file in Python and also how to use the package NumPy. So because it's more like a coding there are many coding examples like how to use those math functions in NumPy. So instead of using a slide, I will just show everyone directly on the Jupyter notebook. And after the course, I will share this notebook to the Moodle so everyone can practice. We briefly talked about those CSV file and TSV file last week, like we can use pandas, which we will cover next week to read those files. But sometimes, for example, this is a kind of file we want, like everything is well organized, like each column represents some information. And for example, this is, I think it's some kind of fish, and some of them are healthy, some of them are not healthy. And also the length is the length of the fish. We want this kind of file, like you read it directly. But sometimes especially some like large language file, like text files, or some you just got using a tool to extract all the information from, for example, from Google and from a website, you want to just extract some information from there. So those files could be very ugly, I mean, the format. So what we will do is we can use the Python. They have this inherent open this function. It can just help us read those files one line and by another line. This way, no matter how large the file is, or like each line, no matter the length of the line is, you can just manipulate each line by each line, so on and so forth. So the way to use it is this way is this is a package. I mean, I didn't discuss last week. Usually, if I want to, for example, work on this file in this specific location on my drive, instead of using, I mean, I can copy this and paste here and to ask the function to open that specific file in that location. But I can just using chdr to change the working directory to this location. And after this command, I can just operate all the files in this specific folder without showing that location. So the format is we can first open this file using open this file. This R means I read this file instead of write the file. So then it's open. I can just maybe using a for loop, like for line in file and print line. I just for each line in that file, I just print it. And actually, let's see how it looks. You can see everything, including the headers, are printed out to the line. And also sometimes, usually we want to do something to the file. For example, the function, this specific function I mentioned last week, right? Split. I can split this whole line by comma, and just using comma to this, and using like data to rep. After split, this will turn into a list, and I can, for example, I can just print the first element in that list, which is this string. Let's see. Yeah, it's just the first column. Yeah, we can if we just for example, we want to get a list to get all the, for example, we want to using a list to record all the length of those fishes. We can maybe append, I mean, each time just append the third column and put it into this into this list. And that's it. We can check the length, like, yeah, in total there are 81. I think it should be, yeah, this is 81 because I mean, I didn't skip the first line. So I mean, the header is also included in that list. Yeah, that's basically how we can handle a file using the Python's inherent this function open. And also, please remember, if you do it like this way, like file open, you have to, I mean, it's better to close it at the end. Otherwise, sometimes the memory will mess up and just other command will just write something to that file. But of course, there's a easier way. I mean, we can just using this with function. I mean, with keyword. I can just say with open. And similarly, I just do the same thing. Sorry. I just do the same operations. This time, oh, mhm. Oh, yeah, yeah, that's right. With open, yeah, no, it's correct. Yeah, I forgot to, yeah, I just use a previous variable and which is already closed. So yeah, this command will just open it and you can do whatever you want to the file and you don't need to close it. It will be closed automatically. So sometimes we want to, like, for example, open this file and also in the same time, I open another file and save the information in the first file into the other file. I can create, like, this is F1, and then I just open another file, open like a fish, another file called fish length, as write. This way, each time I got the, for example, the information, I think I can just save it to the, I think it's, let's see if it is correct. Oh, it's F1. No? Okay. Oh, yes. I haven't used this for a long time after, I mean, when I know how to use pandas. So yeah, this right, each time only takes one input argument. So if we check this, you can see everything is just, yeah, I just get the third column and paste it in another file. Yeah, that's also a way to handle this kind of data. Yeah, that's just about the Python inherent I/O. Usually, after we learn pandas next week, in most times we won't need to use this. Any questions about this? No? Okay, let's jump into NumPy then. So NumPy is a package for like manipulating matrices. It's very common for data science, especially for machine learning and deep learning. Yeah, usually you just need to handle large matrices. And once we installed the first, I mean, to use NumPy, usually we just import this NumPy at the very beginning. And you might see many, like if you check some online tutorials, you will see people using this NP because it's like, I mean, it's like a tradition, like people will just import NumPy as NP. Yeah, this way, like tell the Python, like in the future, I just using NumPy to represent NP. So let's run it. And yeah, it's imported. Then I can use all the NumPy related functions. For example, the first one is a range. A range is just you create an array like from 0 to the specific number 10. So for example, I can create, you can, it's zero, just 0 from 9. I mean, excluding 10. Um, so by the way, this NumPy 1D array, it looks very similar to a list, but it is not a list. Of course, we can change it. We can specific tell it, I mean, change this. Yeah, we can change it into a list, but uh, But I mean, if you just create using non-arrange, it's just an array. But of course, many of the method, I mean, the slicings, those things are very sim are the same. And another very commonly used, sometimes we want to just create a empty, like all the create an array or create a matrix, every element is zero. And then we will do some calculation and fill in some information into that matrix. So we can just using this np.0. And similarly, we have np.ones. Let's check. So the format is like if it's a two-dimensional matrix within a 3 by 4 matrix, then this will give you a completely zero matrix. And also for ones, I think it's the same format, just to change it. 4 by 4. It's just a 4 by 4 matrix. And if we have a list, let's see, list. We can use this np.array to change this into a list. You can see at the beginning, it's a list. After that, it's a NumPy array. It's just the way, I think it's not Jupyter notebook issue. It's just a VS Code issue. It shows, looks like it's still a list, but actually it's already converted. And if I want to double check, I can actually say at the beginning, if I do it like this, it will report an error because the list doesn't have this shape function. But after that, it will be correct because it's already converted to a NumPy array. Some of the slicing method we will talk about later, it only works on NumPy. It doesn't work on list. So that's why sometimes we have to change a list into an array, NumPy array first, and then do the calculation. So another thing is once we created that array, for example, this ARR, we can actually change it just similar to Java and other languages. For example, we want to change this one, which is in the second row, second column. So we can just using this way, and it will just change the specific element in that location. Yeah. And so and another very commonly used function is this random function. Actually, Python has a package called random package. You can just import random and just using random directly. But NumPy has its, I mean, that random, it generates an element. It's more like the results of the list. But NumPy, the random will just create a NumPy array for you. And this one, the random n will create a normal distribution random number. Let's see. Yeah, it's a matrix, 2 column, 2 row, 3 column, three column, and random is RAND is the same as random n. It's just a uniform distribution. These are actually sometimes useful for machine learning. Like you need to initialize that matrix, but yeah, that's okay if you can't remember it. I mean, in the future, if you use those projects, you can just search these functions and use it again. And also random int is just like the name shows, just a random integer. And the random choice is actually very useful, especially sometimes we want to do some random sampling. Like we have 1,000 people. I just want to get like 500, randomly select 500 persons information from that data set. You can just using this random choice. The first is like this is the array you want to extract information, and the size is like how many of them you want to get, and replace is do you want to replace? I mean, do you want to duplicate in the results? Like those 500 is as a non-duplicate or duplicate, and we can just using this random choice to choice. Let's see. Let's see, three number, I paste. Yeah, it's just random select three number from that array. So another thing is sometimes we read a data set, like a huge data set, but it's too large. I actually don't know how many, like the dimension of the data, like how many samples, how many features. I can just check using dot shape. It give us the shape of that the previous array we created here. And also, it's very common, like sometimes we want to do something like we want to run an algorithm on every element in that matrix. I can see for I in range array dot shape 0. Shape 0 is just the row in number of the row elements in the row. And for j in range shape 1. This sorry, yeah, this way it is just for example, this way it just print out every element in that matrix. And this one is 3. And also D type. D type will will tell us like what specific type this array is. Um, For example, this one, all the elements are float. 64 is just a double value. So I mean, this might be weird. Like I mean, for this way, this AR I created, of course, I know the what type it is. But sometimes you copy some package from GitHub and they do some calculations and they made a mistake, and you actually don't know what is it, which part of the has it made I mean has the error, and you can just check the D type of those intermediate results and see, okay, maybe this one it has some error during the calculations. um, and also this as type, we would just change the type of this specific array. So if we just print out the it will become a double value after the I specific change it. At the beginning, it's integers elements. So NumPy also, because it's I mean it's matrix calculations. Of course, it supports all these different types of calculations. But if it's just for example BRR this way, we just BRR plus BRR. It's just element-wise calculation, like just one by one, and each way we just do it. I mean, we just do it by ourselves. And similarly, if it's just if it's multiply, if it's the same, just element-wise. Sometimes we would want to do like matrix calculations or like a dot product. So for dot product, we can use this function. Specific tell that we, instead of using element-wise calculation, we want to compute the dot product to it, which is 55 this time. Yeah. So another thing about NumPy is indexing and slicing. We show it how we can just using this. I mean, let's create a complicated one. Okay, I created this three row, four column matrix. And of course, I can use those 0, 0 to get the element. But I can also use this thing called fancy index. So it's like assuming I want to change the position of these rows. I want to put the second row into the first row. I mean, I want to exchange these two rows. I can actually just using this way. Um, I mean, second is 1, 0, 0, 2. This, let's check. Now, the second row is just exchange it with, this is like a slicing, like each time I just got one row from this matrix. It's kind of, based on the original matrix, I get some information, create a new matrices. And also, uh, for that slicing problem, so yeah, I mismemorize it. This way is not a delete one row from the matrix. Instead, it's just yeah, from the very end from matrix. If I want to remove a row from a matrix, I can use a function called np.delete. So let's see. And this is the area you want to do operation. And for example, I want to remove the second row, and I tell it it's 0 index, and it's because row 0 means row and 1 means column. So if I do it like this way, yeah, you can see now only the first row and the third row is remain. The second row is removed because I tell the uh, NumPy to remove it. Another function is called reshape. Reshape is like assuming I have an array like I create a one-dimensional array. Why is this? But I want to change it into a 4x4 matrix. I can just using now it becomes a 4x4 matrix. Yeah, reshape will just you can just tell like this is sometimes it's common like you just want to create a random index random matrix, but you want some information in that matrix instead of just 0 or 1s. And also transpose. Let's see. And I can actually use AR equals AR T. So T will just directly transpose that matrix for us. And also there are many other functions if you want to use it very similar to other, it's just for example, np.exp will just calculate the exponential, and they are all element-wise, log2 and, oh, this is not, log1p. Log1p is a very typical question, like sometimes if your matrix has zeros, if you use log, let's see, like if I just using log2, this yeah, it will report a warning like divided by 0 because the first element is 0, which is not okay for log this function, right? Log cannot be applied to 0. Instead, we can just using this log1p, it will just plus 1 to every element in the matrices and then do the log for us. And then the log will not report any error. Also, there are many functions for statistics, like the mean value sum. Sum will just sum every element in the array. And also we can, this just gave all the summation of all the elements. But if I just want to get the row-wise summation, I can just tell like along the x-axis. And yeah, it will just calculate for us. And similarly, if it's just column-wise, if you do a column-wise calculation for us. NumPy also has its own like sorting algorithms. It's very similar to the list sort algorithm, just using quicksort, and the format just it's also the same. Just but of course, I mean this one it's already sorted, so doesn't change a lot. Mm, so let's see, we finish all the calculation and we just we are done. We want to take some rest and we can just save the matrix. I mean save the information using this np.save. This one is very confusing actually because in most functions, for example, pandas, all those things, if you want to save something, usually the first parameter is the array you want to save, and the second parameter is the for example, the name of the array, which is in NumPy is NumPy. Dot .npy means it's a NumPy array. But if you write like this, you will get an error because in NumPy the format is different. It's you need to tell the name first and then do the then the variable itself. Now it's correct. Yeah, you can see it's here. There's a new array called arr.npy, and this NumPy save is very convenient, especially for numerical matrices. If we save it into using pandas like next time, pandas also have a write CSV file like to output everything into a text file, but it will for a large data set it could say cost you like several G of memory on the disk. But if you're just using NumPy, the size will be reduced to like a very small like tens of I see 10 times of the file size. This is because NumPy has a specific way to save everything, like if you just save memory for you. So if it's just a matrix data, so this NumPy save is more suggested. And also similarly, next time if you just want to use a file, I can see the new array. It's numpy.load. This way, we're just loading the data into this variable, and I can continue the analysis. Of course, sometimes I'm just I mean people are we have a bunch of files. I don't want to load them one by one. I can use this CZ. This will just kind of archive, like, combine everything together into one single file. And the next time I just load this file directly. And the loaded file is like a dictionary like object. So it's like for example, when I save it, I said A equals to ARR, B equals to BR. I can also say first equal to this one, second equal to, and next time when I load it, these are the keys. Remember the dictionary we learned like last time, right? This is the key, and you can just using the key to obtain the specific array. So we talk about the dot product for, I mean, there is another function called MUL, which is matrix multiplication. This is specific for matrix multiplication because dot, if it's just like for example, this one, it's a two-dimensional matrix. If we just using dot, I mean, it's also the matrix multiplication. But if it's one-dimensional and or maybe a three-dimensional or n-dimensional matrix, we have to specific use np.matMull. Sorry, MAT-MUL, because that's the specific function for matrix multiplication. And dot will report some, I mean, it won't report error, but it will do a specific way that's like not actually matrix multiplication. And also for I can do something like, for example, I can use np.x by 3. which is just multiply this matrix, every element by 3. So when it's a matrix and a number, it's just the element-wise calculation. If it's 2D, it's a matrix calculation. If it's 3D, it's another thing. But if I just, let's see, I try this one, it will report an error because that specific design for matrix calculation is not okay for this kind of thing. And also, yeah, dot can be used for that dot product. Yeah, this way. If it's just a 1D array, dot can be used for compute the dot product of the two vectors. But matrix calculation, I mean that mat MUL doesn't support this kind of calculations. Any question about these functions? No. Let's while I'm checking those errors I make, so I prepared 2 exercise questions for everyone to practice. Yeah, this is the first one. Yeah, I will explain it later. I will give 5 minutes for everyone to think about it. And for this question 1, so create a 3 by 3 matrix and fill with random integers between, oh, actually, 3 by 3. Oh, run integer. Oh, yeah. So I create a matrix randomly from select number from 1 to 10, and then just in total non-numbers, and this the change is shaped to a 3 by 3 array. And after that, I need to find out the maximum and minimum value. Yeah, minimum and maximum value. And also, yeah, you can see the minimum is 3, maximum is 8. And the third one is we can, of course, using a for loop to do that. But actually, another way is we can just do it like this way. Yeah, this Q1 larger than 5, you just compare every element with 5. And if it's true, and that specific location will be replaced with 0. Otherwise, just remain the same. Yeah. Any questions? No. Okay. Yeah, that's all for today. Here are the 2 exercise questions for everyone to practice. Feel free to come to me if you have any questions about them.